Well, good morning and welcome, everybody. Thanks so much for taking time to come in here and talk about 6th-gen missiles for 6th-gen threats. Dave Nahom, I retired last year out of 11th Air Force. Certainly a topic that's I'm very passionate about. And I'm not sure maybe 6th-gen missiles, like the previous speaker said, might be the right term, but let's just talk about the right missile for the threat that is emerging out there. I've been in and out of air superiority most of my career, and it's certainly a topic that we talk about a lot. So for the next 40 minutes, we're going to not talk about the platform, and we're really going to center a lot on air-to-air piece, the air dominance piece, and whether these are kinetic or non-kinetic munitions. But we're not going to talk about 4th, 5th, 6th generation. We're not going to talk about F-15EX, F-35, F-22, enhancements to those platforms, F-47, next generation air dominant systems. But let's talk about the thing that comes off the airplane that actually completes the intercept and where we're going and really where we need to go. Got a great panel here today. We got General Mitchum, Bull's an old friend, commander of the Integrated Capabilities Command. Jason Bartolomei, Brigadier General Jason Bartolomei is the commander of the Air Force Research Lab. Brigadier General Bob Lyons, director of the Armament Directorate for the Air Force Life Cycle Management Center. And Mr. Sam Deneke, so we make sure we get a industry look at this, the president of Air and Space Defense Systems at Raytheon, an RTX business. I really want to get right into the questions. So what I'm going to do is I'm going to ask each one of these a question, each one of our gentlemen up here a question in order. And I'm going to give them 33 seconds to kind of open up, introduce themselves, and how they're part of this conversation, why they're relevant to this conversation. And with that, we'll get started. Right? So, Bull, General Mitchum, to begin with, we need to define the threat. What do we mean by 6th-gen threats? What threats characterize a new 6th-gen or modernized, and what characteristics are new to 6th-gen and relevant to how we kill them? And how do these threats change in our assumptions about speed, maneuverability, and survivability?
Great. Well, first off, thanks for moderating. Thanks for having us here. Thanks to our sponsors for the opportunity to talk about this. I'll begin by saying I'll probably exceed the 33 seconds. But you know what I'll begin with is first off, say that we are seated here in an order, and it's meant to be a logical order of kind of how we think about this. And it's so important that we link a discussion about the threat requirements all the way through our various Air Force entities and ultimately our asymmetric advantage, I believe, in our country to win as a nation, which is our industrial base. And it is the innovation that's spurred by our system of, frankly, government, of capitalism. So you're going to see a theme through this of kind of how we move through that and how we bring coherence and understanding where we need to head, how we frankly invest our talents and our capital as a nation to be able to achieve the problems specifically here now that the nation expects the Air Force to solve on behalf of the Joint Force. So over the last year in our journey on Integrated Capabilities Command and our provisional status, we've focused on 3 things that I think all bear on this. The first and foremost, this is all about accelerating the delivery of capability to our airmen to give them capability that wins and deliver that to the Joint Force as a whole system, not a collection of individual systems, but focused on the mission. That alone gets us so far. We also have to ensure that we're doing the best we can with every dollar we have. And that's a cost per effect discussion. We also talk about lethality per dollar. And we have to address both sides of that equation. And all of that comes together, as I mentioned previously, in prioritizing missions over individual platforms or systems. So when we take that lens now to the problem that's laid out here and we talk about the threat, it's not one 6th-gen platform that we're targeting. There are things that we will refer to as 6th-gen platforms, but it is really about a future threat that is characterized, a future environment, by this persistent surveillance, by this deep system of systems. When we grew up flying, we thought about a individual platform against an individual platform. And in our worlds, that maybe began as we would exploit a radar notch and we'd do a Doppler notch, and then we'd think about adding some chaff, and we're defeating either that specific individual weapon that's coming at us or the host radar. That is not the environment we operate in. There are going to be so many things leading to understanding that battle space. We must think about defeating the system. And weapons are a key part of that, but they're not the only part of that. And what that drives us towards thinking, especially the discussion of mass that has come up, we are going to likely have some very high-end systems that are bespoke to close certain parts of the kill chain, and we do that better than anyone in the world. We do it today, and we're going to do it in the future. But we also have to balance that with mass and our ability to produce and leverage the industrial base. And frankly, the two best people in the Air Force, thought leaders, I think Bob asked me to refer to them as action leaders, when it comes to how we leverage that and we communicate the affordable mass and ensure that it gets the effect and solves a problem are these two gentlemen next to me. So thrilled to be here. And I just encourage you, think about a holistic system of systems, not an individual threat that we're trying to face.
Okay, and General Bartolomei, what characteristics of a 6th gen threat require new capabilities or approaches for missiles and systems originally designed to counter 4th and 5th gen threats?
Yeah, thanks, sir. Before I get started, just to let everybody know, AFRL, we've got about 12,000 people that are committed to winning the future for the Air Force and the Space Force, and maybe no mission is more exciting than the weapons mission. So I'll start by that. So, sir, where my mind goes when we think about this from an S&T standpoint are sort of two characteristics here. One is adaptability and scalability. So what we're seeing right now is the pace of technological change is moving pretty rapidly, and the dynamic threat environment is thinking that way. So when I think about 6th gen weapons from an S&T standpoint, what I'm thinking about are weapons that look and feel more like Christmas trees that we can hang ornaments on. So if you look at a weapon of the future, it's one that is modular, it's open, it's software defined, it's more like a bus, and that bus can be manufactured in an inexpensive way, preferably, and that we can dial in the capabilities like ornaments on a Christmas tree to be able to do the things that General Mitchum is asking them to do. And from an S&T perspective and a lab perspective, we have folks working with industry partners all across the laboratory on all dimensions of that. From network collaborative autonomous wolf packs of weapons, where you're gonna see homogeneous and heterogeneous mixes of different sized weapons getting into battle space to do things like comms, sensing, and strike. Ladies and gentlemen, those capabilities are already available to us today. All the way to software-defined weapons where we can, in a sortie, learn from what's happening, come back and upgrade so that the next sortie does something that the bad guys don't want to see happening. This is an amazing time to be a technologist, both in industry and in the laboratory. And one thing that is sure, and I really am looking out around the room here, and I see a lot of friends and a lot of new faces, but this is a win-together moment, I think, for our industrial base and our service. And one thing that's great about the panel is I really like this guy right here, and I love working with him, and I really like this guy, and I love working with him. But I'll tell you that it is going to be both cooperation. And so one of the things that we're really proud of is weapon open system architecture that started in the laboratory, WOSA, and has been fully adopted by General Lyons' portfolio that actually was a collaboration with industry and the government to agree on some of the basic principles on how we're gonna design the weapons of the future. Wow, that's a powerful idea. And then setting up the relationships between the laboratory and our leaders in acquisition to be able to accelerate the capabilities into the fight. That's happening right now, and looking forward to more of the discussion. So very interested in what you have to say, Bob.
Yeah, thanks so much, Jason. So Bob, General Lyons, recent conflicts have shown us that iteration and evolution in warfare is important to the capabilities that we bring to the fight. How are you thinking about adaptation and the ability to iterate quickly in both hardware and software?
I think about that every day. I want to first thank everyone for being in here and having an interest in this topic, and for all of you that are involved in the fielding of weapons for the United States and our allies and partners. Great, thank you. I'm the Program Executive Officer for Weapons. I'm stationed at Eglin Air Force Base. Eglin Air Force Base is a national asset. We're able to do test, acquire. We've got lab down there. We've got the 53rd Wing that can take the ideas and translate them into an operational assessment. And we're able to do a lot of great things down at Eglin. That's going to be key to my answer to your question. As a program executive officer, the job is focused on execution. And what that specifically means is to make sure that you make decisions, you get on contract, and you execute the program in a cooperative fashion with all those involved in delivering the capability. That ranges from a 9mm bullet to an exquisite hypersonic weapon, air-delivered, air-to-ground weapons, air-to-sea weapons, and air-to-air weapons. And it is an exciting place to be, and it's an honor to serve there. So now let's talk about the iteration in conflict. And I see some young NCOs and officers in here, and I'll tell you, when I was a lieutenant and captain, when I signed up, I did not know that I would end up in the Middle East in a few years from joining the service at LA Air Station. A few years later, as a lieutenant and a captain in the Middle East, I was with depot teams closest to where the B-52s were, special operations, ground forces of all services, around people that flew fighter jets. And it was from that I learned the importance of you have to be in the environment to learn about what's going on inside the environment. The people that are doing the tactics and operations, and the people from industry that make the product, and the people that do acquisition in one place, to be able to rapidly see what's going on in the operational environment, come up with a plan and do something about it. So fast forward to today, there's a couple of things that we should think about. In my journey of the past year, I went over to Europe, had a chance to sit down with the air component commander over there and hear what was going on the battlefield. And it's the same thing that I remember as a lieutenant. When you're in conflict, you learn what has to be done from an engineering standpoint or a tactics standpoint, and then you've got to go do something about it. It's happening right now. Middle East and Europe, it's happening. So the first thing it starts with is having a profound understanding of what the environment's like. 2, there's an administrative process to get on contract, meaning that you should have your money preloaded. You should have your contracting mechanisms primed for speed. Some of the ideas that we had at the time were having a thing on the contract where money was already obligated on the contract, and then we could cut a couple sentence task order, and we were able to start that day. Another thing that's very promising about today's environment is the way we're building the products. The modularity, the open systems is a serious matter. Right now, we have an opportunity to build things faster than we ever have, with fewer parts in the design, modular designs that you can swap in different things. And in the past year, we've seen from idea to contract award, first flights of prototype designs within 4 to 7 months. It's our affordable mass portfolio. And we're about to embark on, and it was all successful, and now we're about to embark on the production of the first 1,000 missiles starting this fall. And within 2 years of contract award, we could have 1,000 missiles on the shelf. That is fast by any measure. Thanks for the question.
Thanks. So let's kind of switch gears to industry now. Mr. Deneke, Sam, missile capability and costs have traditionally followed the same path, up and to the right. We keep asking for more speed and range. If we keep asking more speed and range, we'll really quickly price ourselves out of buying the quantities we need. How is cost a factor in your thinking, your company's thinking, and industry at large?
Thank you. So by way of introduction, so I'm Sam Deneke, so I'm the president of Raytheon's Air and Space Defense Systems. Come from a bit of a unique perspective. You know, when General Mitchum talks about systems and systems of systems, you know, the ASDS portfolio is not just weapons. I do have all of the Air Force weapons for Raytheon in the portfolio, but also space payloads, space mission control, and ground-based radars like TPY-2, OTHR, and EWR. So that is pervasive in our organization. We're thinking about the entire kill chain and how it all works together versus a focus just on the weapons per se. And I would say that, yes, the traditional trajectory has been up and to the right as you're adding capabilities and you're getting more and more bespoke and more mission specific. But I do think that there is ample evidence out there of a more P-cubed-I approach where you're adding capabilities that you need to existing weapons, and I think there's a place. I think there's a place for both of those, certainly in the ecosystem. So it's certainly true that culture is one of the big things within industry that needs to change in terms of how we're thinking about the fight at hand and the rapidity by which we're fielding new capabilities. You know, I got 10,000 patriots that do this for a reason. They're in this industry because they believe in the mission and they believe and given our warfighters an unfair advantage. But how that manifests itself a lot of times is we can add a little bit more. We can add a little bit more. We can give our warfighters a little bit more. That's the enemy of speed and of cost when you don't have a firm grip on the requirements and what's good enough, because you know a missile that's 3 years out, even though it's a little bit more capable, in the conversation we're having today, isn't as good as something that's 95% that you can have in a year. So that's the big focus, and a lot of what we're doing are those bespoke, high-end, the 6th generation hypersonics. That's in the portfolio, but a lot of it also is focused on how do we modify to add capability, keep that price point where it's still affordable, and our warfighters can have capability at scale.
Thanks, Sam.
Hey, sir, can I build on
Yeah,
just
please.
the last two? Really interested in what was just described, and I think General Lyons hitting on just the power of speed. I mean, just think about what General Lyons just said, is that in the last 18 months, we have seen 2 cruise missile-sized weapons that went from a piece of paper to flying. One, it shows the power of industrial might. It demonstrated the fact that not only the big guys, but even new entrants are capable of producing something that can have a big impact in the fight. But when you think about like what made that possible and why this collaboration win together thing is so interesting, especially from a place like the laboratory, is if we are able to collaborate on some of the basics of the design of the missile, the functional partitioning of the different pieces, what it does is you don't have to spend design calories thinking about something that you'd have to spend a lot of time thinking about. Meaning that if you listen to what it is that General Lyons is asking for, which is a WOSA compliant design where the design partitions are pretty clear and understood, that allows you to go a lot faster because you don't have to make a lot of decisions and trades because they're already sort of made for you. And what you're seeing is going from a piece of paper to something flying, and I think Bob said 1 in 7 months and 1 in 9 months. And I don't know if you are tracking Ursa Major, but Ursa Major went on contract in February, and they are scheduled to fly in December of this year. So I think that one is that it's a good news story for collaboration. It's a good news story for American industrial might. It's a good story for what the Secretary talked about yesterday as innovation. And for the S&T community, when we abide by those, the great things that are being developed by the sensors guys, the guys that are developing the next generation warheads, the guys that are thinking about autonomy and network collaborative thinking, they can plug right in. And that, to me, is bad news for the bad guys.
So I'll take it up just one layer from there to amplify. I think part of, first off, tremendous work that this team has done to make these things happen. But it starts with the idea that we focused on, and I know some of the people who did a lot of the requirements documentation for that are sitting a couple rows from here. It started with a focus on the problem, not building the next iteration of the whatever weapon we already own. It was focused on the problem. And I think that is so important for us to think, because that problem or gap-focused approach gives us the flexibility to look at the complete design space and leverage all the ideas in industry, whether that's a weapon or it's non-kinetics or whatever that might be, to solve the problem. And the design signal that myself and Ms. Gentry, the demand signal, out to industry that was sent out last Friday focuses on those problems in line with force design to help translate what are the key problems we think the Air Force needs to solve in a prioritized manner over different time epochs. So As we think about the opportunities to redo how we do the requirement system, which I think we are all excited about, we have to focus on the problems, the attributes, and make those documents as thin as possible to let these three next to us just run and leverage the broad nature of the industrial base.
Okay. So,
Sorry.
Go ahead, please.
No, I mean, it's too good.
Yeah.
So what Bull is saying, and you got to listen really carefully, the problem is to win and have an effect in battle space. And when we talk about a dynamic battle space, that problem evolves. Like what we're seeing right now, I had a chance to go and visit USAF as well, and I'm sure Bob and I heard the same thing, is the pace of change on the battlefield is very different than the classic idea of a single requirement that we spend 7 to 10 years fulfilling, because what we're seeing right now is the battlefield is changing so rapidly. So, the idea that Bull is talking about, which I think is really right, is the type of partnering and adaptation and agility that you've been putting on the net, Bull. We have to be able to respond to it because things are changing so rapidly. So it has to be an open dialogue. I don't know what you think about that, Bull.
I agree.
Yeah, I know you do.
I lost control.
I'll let you regain control of your panel.
Yeah.
But no, I couldn't agree more. So
Yeah,
thanks,
exactly.
Jason.
Yeah, and it's a great conversation, and really, it's at that on a very large scale where we're going with some of these advanced weapons. I do want to drag us down and drill into some specifics, though. And I said I wasn't going to talk about platforms, but I kind of have to in one thing. I'll send this over to Bob during Lyons. One of the challenges, one of the frustrations I had growing up as an operator in this world was integration into the platforms. When we would see an advanced weapon come online, but then we would wait years for it to be integrated on our platform where we could actually use it in a battlefield. What are we doing to address the challenges of time and money to integrate the next advanced missile into something, let's say, an F-35?
That's a great question. I had experience with that firsthand at the F-35, and I was fascinated by how fast we can actually go. We have a really good vignette. It took about 30 days to field something when there was an imperative to do so, where prior to that, I wasn't really sure what kind of timeline we had. So there's a human part of this. There are policies and different entities that have to touch something in order to make that decision to move out. So on the technical side, we have to get the integration of the airplane to the weapon outside of the operational flight program. That's the software in the airplane that integrates all the stuff in the airplane with the weapon. If we can get outside the OFP, my opinion is we can go faster. Another way is you could look at the bomb racks that we build. Is there a way to make those smarter type bomb racks? And it almost seems like no matter what you ask for, it's about a year when you look at what people put down on paper to get through the software part of it, the integration and test in a laboratory or a lab, systems integration lab, and then flight test. And there's this whole, almost a linear process that we have to do to get something fielded on an airplane. So I think we got to go more virtual, more digital, that connects the weapon to the airplane in better labs. That's a great way to do it. And then there's the mindset and the approach of integrating a weapon on an airplane and the people that are responsible for driving that. And we have a phenomenal example of doing that with an APKWS 2.75-inch rocket on 2 fighters. And the speed by which that was done was unprecedented from what I've experienced on active duty. And it has a lot to do with the 96 test wing and the mindset to put the full resources of that base to get it to happen. It was the interaction with the lab, industry. So I know that there's a way beyond the technical part of this there's technical in there as well. We've got some really good examples of how to do that. So going forward, recommendation is modular, digital for the software, better labs so that when you test a weapon and airplane integration, the first time you put it on an airplane has a higher chance of working. And then being poised throughout the entire enterprise from the lab to the program execution to the test to the ability to deliver it and train it to the operator. We've got some great recent examples of that.
Yeah.
How's that, sir?
Yeah, perfect.
And if
I'm sorry, dude.
I was gonna jump in on that. So General Mitchum described kind of the lineup and why we're seated the way we are. In a more optimal view, you could switch General Lyons and I in terms of the position. And so too often it's the requirements, right, where it flows down to industry and the requirements are set and it's on industry to kind of make it work. So if it was more fluid that way in terms of the requirements definition and what's possible and how do we work at speed versus trying to make it work when it gets to industry to physically go do the work, that's a way that you could think about it in terms of going faster on some of these efforts we're talking about.
Yeah, and we have talked about that for a while. You know, very often we don't know what the question to ask because industry can tell us what's possible. We may not know that. So the next one I kind of want to drill down to, changing the subject a little bit, and Mr. Deneke, Sam, I'll send this to you. Let's talk a little bit about AI and autonomy. You know, when you think about it from target recognition, mid-core maneuvering, and even end game. You know, how is industry ensuring that we have reliable, ethical compliance in autonomous engagements?
Yeah, certainly we're on that journey at this point. A lot of velocity around the developments associated with that. We are developing internally as well as partnering where it makes sense. Good example is on SDB2, where we're partnered with Shield AI to bring HiveMind in that solution. And collaborative way of looking at things. The other way that we're looking at things and employing it is also in the manufacturing space. When we talk about velocity, we talk about getting massive munitions out at cost. A lot of it has to do with how these things go together, how complex they are, the incredible technology that we're talking about, but how do we employ AI predictive analytics on the manufacturing floor to be more predictive, to move at scale, and to eliminate some of those things that have plagued the industry for decades. So that's a huge focus for us as well.
Yeah, okay, next drill down topic, I'll go to Bull, General Mitchum. What are the trade-offs? What should be non-negotiable for the weapons we're going to put on our platforms?
So you've come to the ultimate pragmatist on that. I don't believe, with a couple exceptions, tying back to what the team here has said, I don't think anything should be off the table in the trade discussion. And if we get back to the cost per effect, lethality per dollar, depending how you do your numerators and denominators, we got to address both sides of the equation. So we absolutely have to be willing to make trades on performance and to ensure that good enough is good enough, and we don't keep striving for things that we would like to have but that are actually impeding our ability to fill the mass we have to have. So we have to be disciplined on that, and we have to actively engage, not just at the PEO level, which is so incredibly important, but as the representative operational requirements and how things tie into that bigger system of systems. We have to be engaged at every step of the process as we do the triad of cost, schedule, performance, of actively having that discussion. So the only things that come to mind for me that are non-negotiables is the interoperability aspect, the WOSA, the open system architecture, those type of designs that drive down integration, that drive down building in kind of the manufacturability, from day one. I think those are just foundational mindsets we have to approach. Because when we talk about that weapons integration, it's not just about all the different weapons we have to integrate, but at that higher system level, that's, as you know well, you live this, it's directly competing with the ability both in the dollars and in our workforce to integrate Mode 5, M-Code, crypto modernization, all the other things that we have to do for our SATCOM and our C2 links. We've got to remove and detach as much of that as we can to free these things up and remove the dependencies. So that's really that kind of open system and that ability to integrate quickly. Other than that, I think everything's on the table as long as we focus on solving the problem.
Okay, yeah, please.
If we have designs that are built to produce from the start and have the attributes that General Mitchum described, we will have the ability to adapt whatever that product is to what becomes non-negotiable. drives in flexibility for that kind of change. And that's critical when you're in a combat type situation as well. So on the requirements, what works really, really well at this time is a very brief write-up of what the attributes are in priority, but not, you don't ask for everything. Very brief. Do a quick collaboration with people that are closest to the tactical and operational part of the combat, feed that into the design, have an interaction with industry about how to get there, and allow the trades to happen in order to get that product. So for example, my opinion is this: if you sequence your first delivery and you've determined the simplest, fastest way to get something, it may be about 80% closer to what you really want to do. So for example, if you build a device that launches from the ground and it goes up in the air and it strikes a fixed target on the land, that's a relatively easier type of a target. And then if you build the design in a modular way and you want to change the front end so that you can seek out a target in the air, you've already done the systems engineering, the modularity to do that, and you have a lot of flexibility with that. So the short requirements and just listening about what is not negotiable. Yeah. It is the way that we design it to build in the flexibility from the start.
Well,
you like it?
And I think, sorry to interrupt you. Yep. And I think that was a perfect question to ask, because focusing on what's non-negotiable, meaning that the rest of it is tradable, is the right way to think about that, and have those discussions up front and be willing to have those conversations over and over again. Because, you know, again, when it comes to industry, and we can come back and tell you where that knee in the curve is in terms of price, in terms of velocity, in terms of all the things that are critical at this point, too often we anchor in on these things that we don't even know where some of these requirements came from, right? And so having that courage and the agility to have those conversations, not just once, but multiple times throughout the life cycle where we're fielding or we're producing these things, is one of the biggest enablers for velocity.
Yeah, and real quickly, and I'm going to change gears because I want to get this one question. And actually, keep your microphone up there. This is for you.
Keep it up. Keep it ready.
Jason, General Bartolomei. Let's talk real quickly about kill webs. Okay. Is the traditional concept of fighter missile-based air-to-air engagement over? Are we moving to something different now?
Well, I really liked what General Mitchum said. And when you think about, you know, what we present in the battle space, I think we have always and we will present a warfighting system of systems, where when we present forces in combat, there is a natural relationship between what we do, not just in the air domain, but in the space domain, working together. And what I really like about what General Mitchum and under his leadership and the team is, and really driven by the chief, is by looking at things holistically like that and then designing and buying things through that lens, what it does is it opens up lots of opportunities that you don't see when you only look at the particular things that exist in that system of systems. So this idea of a kill web is like a really powerful idea, because you could think of a kill web as a warfighting system of systems that are capable of generating kill chains at scale, different kinds of kill chains. And so I think that the future of warfare, and at least the way we're thinking about it from a laboratory standpoint, is like, how do we lead turn both the Air Force and the Space Force with this realization that we fight as a warfighting system of systems? And then where are the biggest opportunities that we can weigh in to basically give ourselves a battlefield advantage? I think what you're seeing with more modular weapons that are able to communicate to each other, that are able to do what General Lyons says, is upgrade different capabilities as we see fit. I would say that we talked about the problem as if the bad guys don't have a vote. And so some of the things that we're talking about needs to be adaptable to respond to what the bad guys have done. And in some respects, the bad guys are telling us what the problem is. We're just going to be faster at solving that problem. And that's what I think the advantage of thinking like a kill web does, and thinking about it in an integrated way. And that's the way we're thinking about it in the laboratory. That's the way we're thinking about it, not just with this PEO, but this problem is a PEO C3BM. It is a PEO fighter. It is a PEO mobility. It is a PEO weapon. It is a PEO space.
Hey, and well, before you, because I'm going to give you the mic next, but we're running close to time. And I want to give each of the panelists, I'm just going to kind of give a really open-ended question at the end. You know, there was a day when in air-to-air, you'd line up 4 F-15s on one side, you'd line up the adversary on the other side, and he with the biggest missile range won. And that was kind of the thing. There was tactics and other things we can talk about. But then what changed things quite a bit is when the F-22 got introduced. And you started talking about stealth, and it really changed everything. What I want to kind of go in order is we got just a couple minutes left, and this is like 33 seconds times 2. That's about all you get. But what is the next big thing? When we're talking about weapons, missiles, kinetic, non-kinetic, what is the next big thing that's going to change how we actually fight? And let's think kind of an air-to-air mindset. Great.
And there's a clock in front of us, so we'll try to be diligent. First off, I go back to General Bartolomei's point, the question you asked on the organic kill chain. We talk a lot about kill webs, because that brings an infrastructure and a way of thinking about things that is not how we've approached things in the past, particularly in the Air Force and particularly in the air-to-air domain. That is, we talk a lot about, because I say new, it's emerging, it's complicated, and we must talk about it, and it's incredibly important. But I do want to be clear, we must retain organic kill chains, because we can't make the whole infrastructure that supports that kill web frankly, so attractive as a single point of failure to an adversary that all they know they need to do is not defeat our platforms, but just defeat a C2 node or whatever that might be. So we have to do both. So I just want to be very clear that it is incredibly important, and I want every adversary to know we will complete organic kill chains. And that's not going away. We're going to build on what we do, but we also know that's insufficient. So I've already burned up my time, so I will get to what I will close with, because there'll be some specifics here, is I very much appreciate the panel. I will again take it up a notch to say, I don't know what the next big thing is, and that should give us pause. And that is why a resilient system of systems is so important, because you brought up non-kinetic, and I mentioned it early on. If I can solve a problem, produce an effect in time and space against an adversary and deny them the use of a capability, do I care if it blows up or it sinks to the bottom of the sea, or just that they are unable to impede my mission? We need to focus on that. And there's probably sometimes yes, sometimes no. So if I can do things at a cost advantage through non-kinetics that prevent me from having to use some of these kinetic things, I, from a system of systems and enterprise approach, can invest those dollars elsewhere. So we got to be very open to the range of looking at problems. Weapons are always going to be a big thing, but again, I'll hit again. It's the mission, the enterprise over individual systems, I think, is the key to the future.
Yeah, thanks, Bill. Jason.
So I think that in some respects the future is already here. It's how we knit it together. So when I look out at what you all are doing in industry, what I see is technological convergence, where you're taking things like the ability to fabricate, you're taking things like generative AI, you're taking things like General Lyons described as digital, and you all are discovering ways to take advantage of those things in ways that we've never seen before. And I think for us in this room and our coalition partners up there, our ability to do that together in a way that aligns with what we need to do to get an advantage in battle space, the innovation and the spirit that we have in this room, that is the next big thing, is how do you harness that and do it together? Because we have long been the most innovative society in human history, and I think we will be, and figuring out how to keep doing that in a way that puts us on a path to where we're winning together, that really is where we need to go. And so I'm super excited, and if you guys think you have some big ideas, we want to hear from you.
Yeah, Bob.
There are several big things in motion, but I do know this, that it will be up to the people in here and what they harness to get to whatever that is. And I see a couple of people who's right in the line, General Massaro, General Nehemiah, and General Shipton. Thanks for being in here.
Yeah. Sam.
I didn't expect General Lyons to go so quickly, but I was already comfortable with the fact I wouldn't get a chance to close. But your missile's only as good as the kill chain that it plugs into, quite frankly. And so that's the next big thing, right? Is integrating space domain, all domains, both the sensors and data fusion and all of that, and leveraging that for the capabilities of the missile.
Yeah, well, thanks all. Just to sum it up, going back to my time flying and being part of the Air Superiority mission, one thing that made us better as a nation, we do have the best industry, and that is the asymmetric advantage we have. But there's things we do differently. We field equipment, we integrate it better, we test it better. We do things like the Weapon System Evaluation Program, where we take young lieutenants out there and we actually put them in conditions with an aircraft, with a missile, going after a target. So when that lieutenant gets in combat a few months later, they actually know that the system works and it will complete the intercept and they will get the kill on the enemy. That whole cycle that we do in the U.S. Air Force and certainly in the U.S. in general is something we do better. And I think continuing that, being very critical with industry, being very critical with the labs, how we integrate things, and being very critical the way we test and evaluate these weapons will make us very successful in the next engagement. I thank you all for coming in here. Again, it's a great topic that's near and dear to so many in this room. So we look forward to your feedback and your comments. Thanks.